Good day, everyone. Today, I'll discuss a critical issue affecting Metro Manila land subsidence. This slow and silent disaster poses significant risk to millions of residents. The study I'll present, titled Disaster in Slow Motion Widespread Land Subsidence in and Around Metro Manila, Philippines, was authored by Rodrigo C. Eco, Kevin S. Rodolfo, Jolly Joy Sulapas, Anair M. Morales Rivera, Alfredo Mahar F. Lagmay, and Falk Amelo, and was published on September 12, 2020 in the JSM Environmental Science and Ecology Journal. Land subsidence, or the gradual sinking of the Earth's surface, is caused by both natural process and human activities, such as excessive groundwater extraction. This research uses cutting-edge satellite technology to quantify the subsidence and assess its causes, impacts, and implications. What makes this issue particularly pressing is its role in amplifying hazards like flooding, storm surges, and structural instability. So let's delve into findings and explore what we can do to mitigate this slow motion disaster. The study had three clear objectives. One is to measure subsidence rates across Metro Manila and its surrounding areas. Two is to identify areas most at risk. And three is to understand the causes and implications of land subsidence to guide preventive measures. To achieve this, the researchers utilized interferometric synthetic aperture radar or INSAR, a powerful remote sensing technology. This technique uses radar waves from satellites to detect ground movements with millimeter level precision. The data came from two satellite missions. One is the NVSAT ASAR from 2003 to 2010, capturing descending satellite tracks, and the last one is the ALOS Pulsar 1 from 2007 to 2011, capturing ascending tracks. They also applied the method called persistent scattered INSAR or PS INSAR, which isolates stable points like buildings to monitor ground deformation over time. This approach is particularly effective in urban areas, where other methods often fail due to environmental noise. Correction for atmospheric and topographic influences were also applied, ensuring the results were as accurate as possible. So let's delve into findings and explore what we can do to mitigate this slow motion disaster. One is the subsidence rates and hotspots. The research found that Metro Manila and its surrounding areas are sinking at the rates of 2 to 4.2 centimeters per year, far exceeding global sea level rise, which averages around 3 millimeters per year. Key hotspots include Camanava, Caloocan, Malabon, Navotas, and Valenzuela. The worst affected area, sinking up to 4.2 centimeters per year, with a total affected area of 67 kilometers square. The Manila proper, subsidizing at 2.5 centimeters per year. And lastly, the Las Piñas, San Pedro Binyan, and Dansvariñas, all experiencing significant rates at 1.9 to 3 millimeters per year. 2. The causes of subsidence. The primary driver is the excessive groundwater extraction, because when the water is pumped out faster than it can naturally replenish, the supporting soil layers compact, leading to subsidence. The study identified zones of depression in groundwater levels in Camanava, Dasmariñas, and Las Piñas. These are areas where over-extraction creates significant drops in water pressure, causing the ground above to sink. Geological factors also play a role. For instance, the West Marikina Valley Fault contributes to vertical ground movement in places like San Pedro and Binyan. However, the subsidence in these areas is amplified by groundwater pumping. 3. Impacts of subsidence. Because subsidence doesn't occur in isolation, it worsens other hazards. Flooding. In low-lying areas like Camanava, subsidence reduces ground elevation, making these regions more prone to floods. For example, during Typhoon Nessa 2011, storm surges combined with subsidence caused water levels to rise by 1.28 meters in inundating coastal areas. Next is storm surges and tsunamis. Subsidence along Manila Bay increases vulnerability to storm surges. The study warns that a high-like typhoon could cause surges of 2 to 4 meters with devastating impacts. Historical tsunamis like those in 1828 and 1863 caused 1 to 2 meter water level rises. Today, the effects would be far worse. And lastly, structural damage. Ground fissures linked to the West Marikina Valley Fault had already damaged buildings in areas such as Muntinlupa and Binyan. The sinking ground compromises the integrity of infrastructure, increasing repair costs and endangering lives. Metro Manila is not alone in facing this issue. Other cities provide valuable lessons. In Bangkok, Thailand, subsidence reached to 12 centimeters per year in the 1970s due to groundwater extraction. By raising groundwater prices and switching to surface water, the city reduced subsidence to 3 centimeters per year. In Jakarta, Indonesia, experiencing subsidence rates of up to 22 centimeters per year. Ongoing efforts include groundwater regulation and relocating major infrastructure away from subsidizing areas. In Las Vegas, USA, subsidence from 6 centimeters per year in the 1960s fell to negligible levels after sustainable groundwater management practices were introduced. This example shows that with decisive actions,
The study
subsidence can be
proposes the
mitigated.
following steps to address land subsidence in Metro Manila.
1 is to regulate groundwater extraction, strengthen regulations, and impose penalties for excessive use. 2 is to promote alternative water sources, invest in surface water systems, and rainwater harvestings. 3 is zoning and infrastructure planning. Develop zoning laws that restrict construction in high-risk areas and reinforce infrastructures in subsiding zones. Fourth is the public awareness. Educate communities on the risk of subsidence and encourage water conservation practices. And lastly, 5 is the expand monitoring. Use satellite technologies like INSAR to continuously track subsidence trends. In conclusion, land subsidence in Metro Manila is a pressing issue with far-reaching consequences. As the study emphasizes, this is a disaster in a slow motion, silently worsening the region's vulnerability to natural hazard. However, it's not too late. By regulating groundwater use, investing in sustainable water sources, and planning for the future, we can mitigate the impacts and protect millions of lives. The time to act is now before this silent disaster becomes a reversible crisis.